Okay, so let's get right into it. Today, we're talking about a new AI model. But this isn't just another chatbot trying to write better poems. No, this one is designed from the ground up to be a world-class scientist. It's an open-source tool built to help solve some of the hardest problems in research, and its name is Intern-S1.
So, for a while now, we've all been watching this incredible trend play out. Open source AI has been getting really good. For general stuff like writing code or summarizing an email, these free, open models are seriously closing the gap on the huge proprietary models from the big tech companies. But there's a pretty big catch. In the one area where AI could have the most profound impact, we're talking scientific research, finding new medicines, tackling climate change, that's exactly where open source models have been lagging behind. A gap has been forming, and it's becoming a real problem for innovation. And this brings us to the core problem, what the creators of Intern-S1 call the AI science gap. They basically looked at the landscape and asked, hey, if AI is getting so smart everywhere else, why is it hitting a brick wall when it comes to actual science?
This chart really tells the whole story, doesn't it? On the one side, you've got high scores for all the general stuff. But then look at that drop when you get to scientific tasks. It's like the models just can't keep up. And the reason is pretty simple. Science just doesn't work like normal conversation.
The Intern-S1 team put it perfectly right here. Science demands that an AI understand really complex and often really rare types of data. We're not just talking about words on a page. We're talking about things like the chemical structure of a molecule, or the sequence of a protein, or analyzing signal data from a satellite. It's a completely different language, and most AIs just aren't fluent. So, how do you solve a problem like that? Well, you don't just build a model that only does science, because you'd lose all that great general reasoning. And you can't just use a general model because it doesn't speak the language. No, you have to build something totally new. You build a specialized generalist.
And that is Intern-S1 in a nutshell. The whole philosophy here was to build a single model that could be an A-plus student in general knowledge and a PhD-level expert in science. It's built to be fluent in both the language we speak and the language of scientific discovery, without having to sacrifice performance in either. So, how'd they build this thing? Well, if you peek under the hood, at its heart is a really powerful mixture of experts model that's pretty state-of-the-art stuff. But then they bolted on these specialized tools. A vision encoder so it can read charts and microscope images, a time series encoder to understand things like seismic waves, and then their secret weapon, a totally new tokenizer built specifically for the language of science. Okay, so that's the what, but the how is where this gets really interesting. They pulled this off with what you could call a three-part secret sauce, a strategy that completely rethinks how you train an AI to be a scientist. It all boils down to these three things. First, they fed the model a very specific scientist's data diet. Second, they taught it a whole new way to read and write the language of science. And third, they put it through an absolutely grueling training camp to make it an expert across more than 1,000 different fields all at once. Let's break each of those down. Let's start with that data diet. The number here is just staggering. Intern-S1 was trained on over 2.5 trillion tokens of scientific data. To put that in perspective, that's more than half of its entire training data. That is a massive, massive focus on science compared to most other models out there.
It wasn't just about quantity, it was about quality, and how they got this data is super clever. They didn't just scrape random websites, they basically deployed AI agents to go out and hunt for the good stuff, the rare, high-quality scientific data. They managed to boost the purity of their data from just 2% science to over 50%, and they built this awesome two-stage system just for pulling clean data out of notoriously messy scientific papers. Okay, second ingredient, the new language. This slide shows the problem so well. On the left, you see how most AIs read a chemical formula as a jumbled mess of individual letters and numbers. It's super inefficient. But Intern-S1, with its new dynamic tokenizer, sees the whole thing on the right as one single idea, one concept, a molecule.
And the results of that tiny change? A ginormous leap in efficiency. This chart shows the compression ratio, which is just a fancy way of saying how efficiently the AI can read science. And look at that. Intern-S1 is about 70% more efficient than other top models. It's not just seeing letters, it's understanding the fundamental grammar of science itself.
And that brings us to the final piece, the training camp. The team created something they call mixture of rewards. The best way to think about it is like training an athlete for a decathlon.
Instead of practicing one sport at a time, a decathlete trains for all 10 events at once, learning how strength in one helps with another. That's what they did here. Intern-S1 learned from over 1,000 different tasks, from chemistry to creative writing, all at the same time, turning it into that true specialized generalist.
All right, so that's the theory. A specialized diet, a new language, and an AI decathlon. Now for the big question. Did any of it actually work? I mean, it all sounds brilliant on paper, right? But you have to prove it. So the team took Intern-S1 and pitted it against a whole bunch of standard industry tests, comparing it to the best of the best, both open source and closed source. So let's check the scorecards. And the results are, well, they're pretty jaw-dropping. On the text-only science benchmarks, Intern-S1 doesn't just hang with the big dogs, it flat out wins. In key areas like chemistry and material science, it's not just the best open source model, it actually sets a new state-of-the-art record, beating the top proprietary models. And it's the exact same story when you start adding images to the mix. In tests covering everything from microscopy to earth science to remote sensing, Intern-S1 consistently tops the leaderboards. It has set a brand new, much higher bar for what an open source AI can do in science. That science gap we talked about, it is officially closing. So what's the big picture here? Why does one model getting a new high score on a test actually matter? Because this is about so much more than that. This is about democratizing the very tools of scientific discovery. Look, what this really means is that a world-class scientific reasoning tool is now in the hands of any researcher at any university in any country completely for free. This isn't just a small step. It could dramatically speed up the pace of breakthroughs in everything from medicine to material science. It's a really powerful move towards making sure the benefits of AI are shared by all of us. Which kind of leaves us with this one huge, exciting question to think about. Now that a tool like this is out in the wild, available to the entire global scientific community, what's the first big, hairy, audacious problem we should point it at?